Okay, so on last Thursday is when we first started this lesson, and that was about the arithmetic sequences, like by the numbers. So if I gave you if I had like 1, 3, 5, 7, we talked about the pattern going on. What's the pattern going on? Adding 2 each time. Good. So what would my next term be? 9. The next term would be 11. Yep. So that's what we did on Thursday, talking about patterns and the common difference. Okay. Friday, we talked about explicit and recursive definitions, right? So if we wanted to know what the 100th term of the sequence was, we could use the formula to figure that out. And that formula was our AN equals A1 plus D times N minus 1. Two most important parts are what?
AN and D, or A1 and D.
A1 stands for?
Number.
A1's our first term of the sequence. So what's my first term of the sequence up here? 1. And then the difference was plus 2. So if we wanted to find, say, the 100th term of this sequence, we can do A of 100. So our first term we said was 1. Our difference we said was 2. What's N?
100.
Right. Remember, N and this number always match, so we have 100 minus 1, and then we would solve from there. Remember that from Friday? Using those formulas. So today we're adding one more portion. It's the last portion of this lesson, and that's the sum of these sequences. So sum, what do we think of when we hear the term sum? Addition, right? So if I wanted to find the sum of this sequence up here, what would I do with all those terms? I would add them up, and you would end up getting 35. Now, that's pretty simple for sequences that only have about 5 or 6 terms. What do you do with sequences that have 40 terms and you don't want to add them all together? Would you want to add all those together? Would it take you a long time?
Yeah.
It would take you time, especially if you made one little error in your calculator. That would be a bummer. Okay, so that is where this formula right here comes in. So I want you to write this in the margin of your notes. So I want you to write SN. SN just stands for the sum of the number of terms. So SN equals N. Again, N stands for number of terms. How many terms are in the sequence? N times A1. A1 is first term plus AN. AN, that's going to stand for our last term. So we have first term plus last term, and then all of this is divided by 2. Okay, so let's practice using this formula using this sequence up here. Let's plug in values. So our sum, or our S of N, what is our N value? Again, N stands for?
The number of numbers.
Number of terms. How many number of terms are there?
5.
5. So our N is 5. What's our A1? A1's first term.
Is this in our notes?
Nope, it's not. We're just in the margins.
1. Oh, right. We're writing this down.
A1 is 1. AN is, what's our last term? 13. Yep. Instead of AN, what could I write? A13. Yep. A13 just happens to be our last term of the sequence. Okay. We have everything. Now we plug it in. We said N was 5. A1 is 1. AN is 13. Divided by 2. Now we just have to solve this. What do I do first? What do I want to do first to solve? Parentheses. 1 plus 13? 14. Divided by 2. 5 times 14.
60?
It is. Divided by 2. Nope, it is not 60.
Is it 74?
It's 70. Divided by 2. 70 divided by 2 is 35. So instead of adding all of these separately, okay, we can get the same answer by using that formula.
So no matter what, that'll work.
Yep. Okay, so this formula right here is going to come in handy when we have more than 6 terms. Okay, so when we have 100 terms, it's going to make it really easy for us to do that. Okay, let's look at your example 5. Okay, it's written a little differently up here. Example 5A, and then this is your B. Everyone following? Okay, we're going to use this formula right here. Our S of n is n times a1 plus an divided by 2. So we need to find n, a1, and an. So looking at A, my n stands for what?
Number of numbers.
Number of terms. How many terms are there?
12.
It tells us 12, so we have 12 terms. So we found n. Now I need to find a1. What's a1?
3.
Which stands for what?
First term.
First term. I know it gives it all to you in A right now. And then, how do we break this apart? What does that mean?
Oh.
How many terms are in the sequence?
25.
12, but our last term, that 12, is 25. So that's technically our an, that's our last term. Since there's 12 terms in the sequence, this right here is our last term. Does that make sense? Why 25 is our last term? Okay. Now I have everything, right? I found my n, my a1, and my an, so I can plug it in. So I have S of n equals n is 12 times a1.
336.
3 plus 25 divided by 2. What's 3 plus 25?
28.
28 divided by 2. 12 times 28.
336.
336 divided by 2.
168.
168. So the sum of that sequence is 168. Notice we didn't know anything else about the sequence. We didn't know the difference or anything. Okay, as long as we have these three terms right here, we can find what the sum is. Okay, let's look at B. Now we have to do a little more thinking first. So still we're finding the same values. N stands for what?
5.
What does N stand for?
Number of terms.
Number of terms. How many terms are in that sequence?
7.
It is 7. A1. What's A1? 5 because
First term.
first term. And then we need AN, or in this case, A7. What's our last term?
41.
41. Yep, we always want our last term. In this case, it's A7.
So what does the 7 mean?
So remember, 7's a number of terms.
Yeah.
So A7 is our last term.
Oh, okay.
Yep. Does that make sense? So now we have everything to plug it in, right? So our N is 7. Our A1 is,
5 plus 41.
yep, 5 plus 41. And then we divide by 2. Keep going, parentheses first, 5 plus 41.
45.
40.
6.
There you go. 7 times 46.
322.
322 divided by 2.
161.
161. And then that is the sum of that sequence there. So instead of typing all of those numbers in your calculator, we're going to use this formula instead. Capiche? All right. About is sigma notation. Okay? Sigma, that's a mathematical term for sum. Okay, so sigma notation is the sum of a sequence. Okay, so I want you to write this in the margin of your notes. This right here, this symbol stands for sum. Okay? On the top of the sum is n. Well, what does n stand for? Number of terms. N's the number of terms. On the bottom, it always has I in there, which is fine. I equals 1. That's the same thing as n equals 1. Okay? So it's always going to, on the bottom, it's always going to be 1 because we always have our first term. So that's why I or n equals 1. And then on the top, that's how many terms are in the sequence. Okay? And then whatever I have here, that's going to be my equation. Okay? If I ever wanted to find the 8th term of a sequence, that would be our equation in there. So I'll give you an example. It'd be like 3n plus 2. Or in this case, it would use I plus 2. Don't let the I confuse you. Think of that as n. Okay? So that is what our original sigma notation looks like. Okay, so let's look at an example. This is not in your notes, okay, but I want to break it down. So it says the sum of the sequence from 1 to 9 is 2i minus 6. Now let's break it down. How many terms are in this sequence?
9.
There's 9 terms in the sequence, so n is 9. If we wanted to find the sum of this, we're still using this formula. What else do we need to find? We found n.
A1.
We need to find a1. How should we find a1 if this is all the information that we have? What do we think?
It's 2.
Hint, hint. How can I use this?
It's 1.
It's like 2 to 6.
So if I'm looking for a1, what is my n value for a1?
1.
1, because it's the first term. So we're going to plug in 1 for I. Does that make sense? Plugging in 1 for I. So we get 2 times 1 minus 6. What's 2 times 1?
2.
2 minus 6,
Negative 4.
-4. So our a1 is -4. Okay, what else are we missing from our equation up there? We found n, we found a1,
AN.
an stands for
The last term.
last term. Well, how many terms are in the sequence?
6.
9.
9. Remember we said n was 9, so we need to find a9. How do I find a9? What's my n if we have a9?
9.
9, right? So we're going to plug 9 in for I, just like we did to find a1. Okay, so we have 2 times 9 minus 6. What's 2 times 9?
18.
18 minus 6.
12.
Oh, not 16. 12. So our an or a9 is 12. Okay? So now we found all of our pieces. Now we can find the sum, correct? Yes? So now we can use this formula up here. So what was n?
9.
9, a1,
Negative
-4
4.
plus an,
12.
12 divided by 2. So we have 9 times -4 plus 12, 8 divided by 2. 9 times 8,
72.
72 divided by 2,
36.
36. Okay. So with this sigma notation, we can find our 3 values in order to find the sum. Okay? At your example 6. Example 6a. You guys have the sum where it says 13 and I equals 1 and you have 3i plus 2. Everyone following?
Yes.
Okay, let's break this apart. What is, first off, in order to use this formula, what are the 3 things that I need?
AN, A1, and N.
I need n, a1, and an. Can we find those 3 things through the sigma notation? Say yes.
Yes.
Yes. Okay, where do we get n from?
The top of the
N is the top number, right? So n is 13. How can I figure out a1?
1.
It's 1.
A1 is 1. I'm going to plug it in, right? Does that make sense?
I thought it was just 1.
Nope. Because remember, we're looking for the first term. So we need to plug 1 in for I. We're looking for the first term. So we have 3 times 1 plus 2. What's 3 times 1? 3 plus 2? 5. That is my first term. Everyone understand why we have to plug it in?
Yes.
Okay. an, well, what's my last term in the sequence? How many terms are there? 13. So we're looking for a13. How do I find a13? Plugging it in. So we have 3 times 13 plus 2. What's 3 times 13?
39.
39 plus 2?
41.
41. So our an is 41. Now, can we find the sum? Yes, so plugging it in, we have 13 times 5 plus 41 divided by 2. What's 5 plus 41?
46.
46. 13 times 46?
598.
598 divided by 2?
299.
299. That is our sum. Okay. All right, so looking at B, it says how can we write the series as a segment notation and what is the sum? Okay, well, let's think about this first. We want those three values, right? N, what's our N? Do we know? Do we know how many terms are in the sequence? No, we don't know that. Okay, let's move on. A1, do we know what A1 is? A1 is 8 because that's our first term. Do we know what AN is? 43, good. Okay, so what are we missing? We're missing N. We need to find N, so we're going to bring in what we learned on Friday. That one equation. Remember, you're not going to have to memorize these. Okay, but we're going to use this equation to help us find N. So let's plug in what we know. Do we know what AN is?
Yes.
AN is 43. What's A1?
8.
8. Do we know what the difference is?
Well, I mean, you can assume that it's 5.
We can find it, right? What's 8 to 13?
5.
5. 13 to 8?
5.
5. So our difference is
I thought there would be 3.
5. We can use what they have, what we have. If it's consistent, we can use that.
Okay.
Yep.
Wait, then we could figure out how many terms there are if we just kept going.
We could, but let's pretend we can't do that.
Okay.
Okay? And then we don't know what N is, so we're just going to write N minus 1 in there. Does everyone understand why I set this up this way?
Yes.
Okay, now we just have to solve for N. What we need to do first is we need to distribute that 5N in. Okay, so I'm going to do 43 equals 8 plus 5N minus 5 times 1?
5.
5.
-5.
Yep, negative 5. Now I'm going to combine like terms on that side. I have 5N. What's 8 minus 5?
3.
3. Now it looks like something we're used to. What do I do?
-3.
Minus 3. So I have 40 equals 5N. Divide by
5.
5. So I get N equals
8.
8. Okay. Is N what we were looking for?
Yes.
Yes.
Yes. Okay, so we found what we're looking for. Now can we find the sum? Can we find the sum?
Yes.
Yes, using this formula up here. So plugging all of that in. What's N?
8.
8 times A1. 8 plus AN.
43.
43 divided by 2. To save time, it's okay, we can keep going. What's 8 plus 43?
51.
51. 8 times 51?
408.
408 divided by 2.
204.
204. Okay, that is our sum. Okay, notice one more thing it was asking for. What did it want us to do? We found the sum. It wants us to write the sigma notation. Okay, so again, sigma notation, let's look at it. Again, this is our sigma symbol. What goes on top? N, which is 8. What always is going to go on the bottom? I equals 1. How do we figure out what goes here?
204.
What?
204.
Nope, that's our overall sum. We need an equation that goes there. What is an equation that will help us find any term in the sequence? We've kind of already found it somewhere.
SN equals.
Nope, that's our sum. Think back to here.
AN equals A1 plus B parentheses N minus 1.
Yep, we're going to use that. Okay, we've kind of already done it, but let's walk through it real quick. So we have AN equals A1 plus D times N minus 1.
You're writing that in
Not yet, nope. We have to find the specific equation to put in the sigma notation. Okay, so AN, what does AN stand for?
the number of,
Any term in the sequence, right? So we technically, that's what we're looking for. We don't know what AN is, okay? So AN is what we're looking for. What's A1?
8,
8. What was our difference?
5.
5. And then we don't know what N is,
Is that the equation?
okay? Close. Now we just have to simplify it.
Oh, okay.
So I get 8 plus 5N minus 5. And then I get 5N plus 3. Notice that's a part that we had over here.
Is that what you plug in?
Yep. So then our last part of the sigma notation is 5N plus 3. Okay. So really, you wouldn't have to do this again. You could pull it from where we got it the first time. Does that make sense? Okay. So any value, if I wanted to find the 7th term, I could plug in 7 to find out what that term is. Okay. That's why we were finding this. And that's why we just had AN here, because I could plug in any value to this. Does that make sense? Okay. Everyone see where I'm at? I'm right here. Okay, it says a flight of stairs gets wider as it descends. Are we going up or are we going down? Descend. We're going down. Okay, so it says the top stair. Well, if we're going down, are we starting at the top or the bottom?
Top.
Starting at the top. So the top stair is 15 bricks. How can I write that in terms that we're used to?
15.
Is what?
A1.
A1, because it's the first stair, right? A1 is 15. Let's keep going. The second stair is 17.
No.
It's the second stair.
A2.
A2, yep. And then the third stair is 19.
A3.
A3 is 19. They just gave us a sequence, so we could write it like this if you guys wanted to also. Okay. It wants to know the total number of bricks used in all 16 stairs. What are we looking for?
Bricks.
We're looking for the sum by the time we get to 16. By the time we get to the 16th stair, we're trying to find the sum of all the stairs together. Does that make sense?
Would it be 16?
Okay. So we need to find what N is, right?
Yes. No.
No, it wants us to find when N is 16, because there's a total of 16 stairs, right?
We'll just count.
Okay. Could count. Okay, but let's practice using formulas to help us. Okay, so we're going to use this formula again right here before we can use the sum. Because we have to find what? In order to use our sum formula, what don't we have yet?
N.
We don't have the...
A1.
We have A1. We don't have AN. We don't have that last term, right? We don't have the last term. So we're going to use this formula to help us. So we are looking for AN. What's A1? 15. What's the difference?
2.
It is 2. Yep. And then what's N? What's the total number of stairs?
3.
16, right? Good. Oh, sorry. Yep, minus 1. So now we just solve 16 minus 1,
15.
15. And then 15 times 2,
Times 2?
2 times 15.
Oh.
Oh, 30.
Yep. And then we have 15 plus 30,
45.
45. Is that my final answer?
No.
No, what does it want?
It wants the total.
It wants the total, so it wants the sum. Okay, so we're going to use what we have. Do we have everything in order to use this formula up here? Do we have N?
No. Yes.
We have N. N16. Do we have A1?
Yes.
Yes. And do we have AN?
Yes.
Yep, we just found what AN was. Now we can plug all those values in. Go plug those values in and then check with me up here. Okay. If I'm looking for n, where do I get n from looking at this notation here?
1.
I get it from the top. So our n is 5. Okay, n is always going to come from the top of the sum. Okay. A1, can I just assume is 1?
Yeah.
No, why not?
Because you have to plug it in.
Right. N is 1, so I need to plug in 1 for n. So I have 2 times 1 plus 1. 2 times 1? 2 plus 1? 3. So our A1 is 3. Yes.
So, but if the top number is n, then how does n equal 1?
Because when we're looking for A1, our n is 1. Yep, good question. So now we're looking for AN. Well, what was our n that we said earlier? N is 5. So I'm plugging 5 in for the equation. So 2 times 5 plus 1. 2 times 5?
10.
10 plus 1?
11.
11. So 11 is my last term. Are we okay there? Finding those 3 things? Once we find those 3 things, we're smooth sailing. We just plug it in. Okay, so we have Sn equals n is
3 or 5 and
5. A1 is
5.
3.
3. An is,
11.
there we go, divided by 2. Okay, so we keep following. So we have 5 times 3 plus 11?
14.
14. And then we have 14 times 5?
70.
70 divided by 2?
35.
35. So our sum or our total of the sequence is 35.